Thanks a lot for having me, and I'm super excited to do this talk. And I particularly like talking about testing, not because it's such a great topic or it's so much fun to do that, but it's such a big pain point. And therefore, with this talk, I want to provide you a very practical guide how you can test observables in RxJS code. And I already teased it, like testing in general is already pretty hard, and adding RxJS to it doesn't make it a lot easier. It actually makes it even harder as we are now dealing with complex asynchronous problems and stuff like that. So testing RxJS code might often feel very intimidating. So what I want to show you is a good way how you can write in an efficient manner maintainable tests, because we don't want tests that no one likes to touch afterwards, and we don't like tests that we spend days and days and weeks just on writing those. And all of that I want to show you without marble diagrams. Marble diagrams are a way for testing provided by RxJS, and I'm, in the very beginning, not a big fan of, and I don't think most business applications just don't need it. But we'll talk about that later again. And without further ado, let me quickly introduce myself, even though there was already this super fancy video in the front. So my name is Niklas Wortmann. I'm a consultant for Evora IT and member of the RxJS team since 3 years, 4 years, something like that. Additionally, I'm also an Angular GDE and doing most of the time as my consultant activities, Angular work, and therefore testing RxJS code. So the stuff that I show you today is my experience and the patterns that I like to apply. So let's take a look at some code, right? So in your code, you sometimes have observables, right? So if you have observables, you want to test them somehow. And you would start for looking at a marble diagram, like how could your observable look like? And you would notice like, okay, off true, for example, is emitting synchronously and then immediately completes afterwards. Doesn't sound too complicated. So let's take a look how a test for that could look like. We're calling a function, subscribing to the observable, and in the subscribe callback, we are expecting the emission value to be true. Seems fair, seems pretty straightforward, right? And the test pass. I mean, what else can we want more from a test? Like 3 lines of code, 5 lines of code with the test itself, and a running test looks great. And what I like to do when I test, particularly when I test observables, I like to do the negative test as well to figure out, like, is my test really proving the thing that I wanted to test? Is the expectation really executed? And when we run this piece of code, we will notice the test still pass. That's weird. That's kind of weird. And it kind of feels like you thought about everything, like it's synchronously executed. You haven't forgot anything. The only thing you might have forgot is that RxJS handles unhandled exception by throwing it at a separate call stack, meaning asynchronously. And as a failed expectation throws an exception, we are in the situation where we are right now. We executed the test. We had our expectation. It failed, but with in the next loop, it would be evaluated and mark the test as false. But at that point of time, the test is already complete. How can we handle that? Most testing libraries provide a so-called done callback. And I like to use that pattern just because it's very explicit when I expect my test to be done. So what I do is I add the done callback function in the test function, however you want to call it. And then after my expectation, I execute it manually. And with this piece of code, the testing framework then knows like, okay, I need to wait for this expectation to be executed, and we are good to go. And now we even see that the test is working and failing as shown on the slide before in both scenarios. So pretty good. So the first thing that I wanted to show you is when you're testing RxJS code, use that done callback to be sure that your test is properly executed. And on top of that, this done callback also provides a done.fail call, where you sometimes are able to explicitly mark a test as failed. It's sometimes easier or better for readability than waiting for the timeout. This is just one of the recommendations I give. And I like this done callback particularly as it's widely supported. Jest uses it, Jasmine uses it, also Mocha supports that. So it's very universally that you can apply that. Okay, that was easy. I agree on that, but this was like the appetizer. So let's look at something a little bit more complex, right? Because this is just executing synchronously. There's not much fancy to it. And also on top of that, it's just one value that is emitted that we are testing here. Observables have the power, or one of the biggest powers of observables is actually that they emit multiple values. So how would we test something like that? Interval that emits every second a value, for example, asynchronously, and multiple values. So how can we test that? So code looks like that, and I now use from just to make it a little bit easier. And this is now also executed synchronously. But what I like to apply here, and this is a pretty straightforward pattern, is just storing the values in an array and then do a manual expectation on that. This just works with the, because they are asynchronous. So the other thing that you could do is waiting for a complete signal. This would also work with an asynchronous observable like interval, for example. So you're just subscribing to the observable, in the next callback, storing all the values in an array, and then perform your expectation in the complete callback when you know, okay, my observable is complete. Problem with that, though, is that you need to have a complete signal. Technically, not every observable needs to complete, like interval does. Interval, by default, does not complete. It just emits every second. You can apply completion operator like take and stuff like that. But in general, it doesn't complete. So, and my actual recommendation at this point of time is just add a completion operator. Usually for your test, you have certain expectations. And one expectation can be like, okay, I expect n values to arrive. Sorry, I expect n values to arrive. This way your test is deterministic, at least, and you're good to go with that. It is not ideal as you're adding code and logic in your test. I'm aware of that from a testing best practice that there are some gotchas to that, but it at least makes your test more deterministic and therefore more reliable. And on top of that, you're adding RxJS code to your test, and RxJS has a test coverage of 98% or something like that. So this is some of the trade-offs that I'm willing to take in this regard. One thing that I want to give a shout out at this place is the library observer spy. It's working under the hood with this array pattern as well, but it's a little bit more feature provided, whatever. It provides more features than just that. So you can also listen for error and complete signals and stuff like that. It's pretty cool. Check it out. Okay. I'm well aware that those examples were not at all representing real world problems or even code. And I agree with that. I totally agree with that. So what I did is I copied some of my code, actually more or less after obfuscating a little bit of stuff, but more or less this piece of code is running in production and it's for an authentication mechanism. So it's in production right now. It's opening a pop-up, performs authentication, and returns whether the authentication was successful or not. And it also covers cases like, okay, what happens if the users subscribe multiple times to the observable, therefore would open multiple authentication processes at the same time. This is handled with the share replay. There's also this weird case where occasionally the authentication service just says like, you look suspicious. I return you a 403 forbidden, and please retry that. So we handled that in a way that we said in the retry when, okay, if we get this weird 403 for whatever reason, try it again. If you get any other error, then bypass it or pass through this error to the subscriber. So the only thing that you have to do to run this test properly is kind of initiate it. So usually when you're executing tests, you should follow AAA criteria, right? So like arrange, act, assert. And for observables, the order of those A's does not apply very well because this is act already. So we're saying like we're triggering our observable by emitting events. And in the case here, we are saying like, okay, when we get a login event, Then we map this to true. This is really just for demonstration purposes now. And this is the public method that is exposed for the users. So when the users try to log in, they call this method, subscribe to it, and are good to go. The cool thing that I wanted to show you now is that the test will look exactly like the others before. So let's have a look. We are instantiating our class because this is kind of stateful. We are having the login with pop-up method that I just showed you. We are subscribing to that, and then we are dispatching the event. So technically, what I mentioned before, we have a range in the first line. We have assert with the subscribe, and then we have act. We need this because observables are lazy. Which would happen is if we would dispatch the event without being subscribed to that, nothing would be executed, as we are not subscribed to it. So, but what I want to show here is that I use the same pattern. I subscribe to an observable, call the done method, and I'm good to go. As easy as that. And the same even goes for error scenarios, right? So my observable can emit an error, and I can react to an error. What I did here is I subscribed to the error channel, saying like, in case of an error, I expect the error to be a certain error, and then say, okay, I'm done. When talking about testing, we now have a good feeling for like how I can write tests. But when we're talking about testing, we also have to talk about mocking, because we might not directly test our observable, but we have a piece of functionality that is affected by an observable. So how can I mock observables? And I want to introduce you to the 6-step mocking strategy. This is not a patent or anything. This is a name that I came up, so feel free to reuse it. But when I start mocking something, doesn't matter if it's in an Angular application, React, whatever, I usually always say, when I have an observable, I start with mocking it by returning never. So I have the observable that I use never instead. What never does, it's returning an observable. So therefore, like all the methods are available. I don't have to deal with problems where like subscribe is not defined, stuff like that. So I have all the methods available, but it's not emitting anything nor completing. So it won't execute any code. This is my first step, just to make like tests run that are not at all affected by an observable, just to make the code executable. Next step would be using off with a single object. I use this pattern when I really want to mock one single value in a synchronous manner. So for example, where I like to use that is if I'm mocking HTTP calls. In a unit test, you wouldn't execute a real HTTP call. With this pattern, you can say, like, instead of executing this HTTP call, return off with a static value, which is a synchronous emission, if you want that for your test. Next step, if you don't want it to be synchronous, would be use off with delay. If you want an asynchronous test for a static value, use off with delay. And technically, I now put here a delay of 100 seconds. You can also use delay of 0. It will also be asynchronous. So this was just for demonstration purposes. Next thing, or next stage that I would apply is using from when I want to emit multiple synchronous values. We have seen that already in the slides before, the way I use that. So when I use from with an array, it will have 3 emissions. First 1, then 2, then 3. Therefore, I can test scenarios where I depend on multiple value emissions. For example, I want to mock out a polling scenario, an observable that polls values and therefore emits values like in an interval. I can do this with from. If I want multiple emissions with asynchronous value, then I usually go for interval. You could also technically go with from and delay, would also work. I personally usually use interval for that purpose. And now that was step 5. And the last thing, the very last thing, if I need full flexibility of the way I want my observable to work, is I use a subject. With a subject, I can mock everything. Here is a quick summary of that. As I'm running short on time, I will move on. So we now have covered testing and mocking. So let me add my 2 cents about marble testing. And in all honesty, marble testing is a great way because they're providing a visual way that represent the behavior of an observable. And usually when we're talking about marble diagrams, we are talking about ASCII marble diagrams, not like that kind of ASCII art, but like that kind of ASCII art. So they come with their own syntax that you have to learn, and they're describing the behavior of the observable. So off true, for example, would look like this in a marble diagram. So we have the parentheses to mark a synchronous emission of having two emissions at the same time. First, the value true, represented by the character A, and then the pipe for the complete signal. Now it's already getting a lot more complicated with interval. Interval would look like that. So we first, because we're starting at 0 milliseconds in a marble diagram, in an ASCII marble diagram, we first wait 1000 virtual milliseconds before the first emission. So we have 0 to 999. Then we have the first emission, and then we wait another 999 milliseconds. So things like that are kind of confusing when you're getting introduced to marble diagrams. And the code is not that easy from my perspective, at least. The good thing about marble diagrams is, and okay, I will skip this for now. If you have questions about the code, feel free to approach me on Twitter or whatever. But I want to share my opinion on marble testing, because what I often hear is this opinion like, okay, if I have to test RxJS, I have to use marble testing. And this is just not true. Marble testing are extremely powerful for libraries like RxJS, because you can test extremely difficult things like very complex scenarios. And another thing, it also helps in understanding like how observables work. That's a great benefit. I have to give that. And it's visualizing the way your observable works. But you have to learn an entirely new syntax that is not really intuitive. You have to know a lot about RxJS and how things work under the hood, which is usually a level of abstraction you don't want to deal with for test. And honestly, it's super hard to maintain. I personally had so far in my career 3 scenarios by now where I said, for this piece of code, marble testing makes sense. And I actually forgot that you're testing implementation details of RxJS, because you can also test like stuff like when does an inner observable subscribe and stuff like that. This is not relevant for a business application. And long story short, if you're not writing a library or the most or like very complex RxJS code, you probably don't need marble testing. I will skip the summary out of time reasons, but it's this nice fancy diagram, so I will keep it for a second and then move on. Thank you very much. I really appreciate being here. And if you have any question, feel free to approach me at any time. I rushed the last couple slides a little bit, so totally open to that. Thank you very much.